What if I told you we could take pictures of planets outside our solar system? It sounds like science fiction, but thanks to NASA's brand new space telescope, it's now a reality. The James Webb Space Telescope has been making headlines lately for its incredible images of the cosmos. But there's another space telescope that just launched in May 2023. The Roman Space Telescope is equipped with an imaging technique never before used in space. Let's take a look at how this unprecedented tech works, and what secrets about the universe it will unlock. To understand how we can take pictures of planets orbiting distant stars. When you think of a hologram, you probably picture those collectible trading cards that seem to have a 3D image inside them. That image is actually just a diffraction grating. Large holograms are capable of recording 3D images with huge amounts of information. A team at the California Institute of Technology has developed a type of large hologram called a coronagraph, which can capture the faint light coming from an object, in this case, a star. However, so how does the Roman Space Telescope plan to pull this off? Its first scientific observations will focus on Tau boats, and since it's only 600 million years old, more importantly though, Tau boats has at least 2 planets roughly twice the size of Jupiter orbiting it. These gas giants are thought to have extremely hot and puffy atmospheres, which may help us detect their weather patterns and search for signs of life. What makes them especially interesting is that they orbit very close to their star, meaning that there will be a lot of light coming from Tau boats that we do want obscuring our view of the planets. This is where Roman's unique imaging tech comes in. Roman's telescope is designed to take advantage of the fact that different parts of light waves move at slightly different speeds when they pass through things like lenses or prisms, a phenomenon known as dispersion. This means that after passing through Roman's telescope, light waves will be separated into different colors based on their wavelengths. This is similar to how a rainbow forms when white sunlight passes through water droplets in the atmosphere. By separating the light into different wavelengths, Roman can block the longer wavelengths, which correspond to redder colors, leaving only the shorter, bluer wavelengths. As the planet moves in front of the star, blue light that was being blocked will suddenly pass through, revealing the planet as a tiny dot in the sky. But why does this technique work while previous attempts have failed? One major issue is that previous telescopes haven't been able to separate light into different wavelengths precisely enough, but Roman is equipped with a high-resolution spectrograph that allows it to achieve the necessary precision. Additionally, Roman will perform a maneuver called a dither. By doing this, it can effectively take multiple pictures of the same thing from slightly different angles. But wait, there's more. Instead, it will take hundreds of images over the course of several years as the planet orbits its star. This will allow scientists to study the planet's atmosphere over time and detect changes such as the rise and fall of clouds or even seasonal changes like the shifting of weather patterns. We'll also be able to watch the planet pass in front of and then behind its star. With this information, scientists will be able to create incredibly detailed models of the planets and search for signs of life, all thanks to the power of imaging technology. Currently, most exoplanets have only been detected through indirect methods. This doesn't tell us anything about the planet's mass, however, just its size, but by measuring the amount of blue light that passes through Roman's telescope. When a planet moves in front of its star, we can calculate the planet's mass. So by measuring the amount of blue light that gets through, we can infer the planet's density. Combine this with data from other telescopes and satellites that measure a planet's size and orbital period, and we'll be able to learn more about the composition of exoplanets and whether they are made of things like rock, gas, or even liquid. The imaging tech on board the Roman Space Telescope is truly a sight to behold. By harnessing the power of dispersion, coronagraphs and dithers, Roman will be able to capture breathtaking images of exoplanets that have never been seen before. Imagine the incredible discoveries that await us as we gaze upon these tiny dots of light and uncover the secrets they hold. Perhaps we'll find planets with rings of their own, or even signs of life. While the tech is impressive, the true success of Roman will depend on the mission's overall design. A mission is only as strong as its weakest link, and there are a lot of parts that need to come together for Roman to succeed. The good news is that NASA and its partners have put a lot of thought and effort into designing the perfect mission for Roman. For example, one of the biggest challenges facing any space telescope is maintaining stability while in orbit. After all, the telescope must be able to capture sharp, detailed images of celestial objects without shaking or vibrating. To address this, Roman's designers have equipped it with a state-of-the-art attitude control system that uses reaction wheels and thrusters to keep the telescope on target at all times. Additionally, Roman is equipped with a fine guidance sensor that allows it to lock onto a target and keep it in focus even when the telescope is moving. This level of precision and accuracy is crucial for Roman's mission to succeed. Any slight misalignment or wobble could throw off the delicate balance of the telescope and ruin the quality of the images it captures. But thanks to these advanced technologies, Roman will be able to maintain the stability and precision necessary to capture the first-ever images of planets orbiting distant stars. However, the Roman Space Telescope was originally planned to launch in 2024. But due to the complexity of integrating all of the various pieces of equipment, NASA pushed back the launch date to 2026. Even so, in addition, now while the cost is certainly a concern, there's no guarantee that the Roman Space Telescope will be successful in capturing images of exoplanets. If it fails, then there are plenty of potential issues that could doom the mission before it even leaves the ground. But if everything goes according to plan, then the Romans. So stay tuned and get ready for the incredible discoveries that await us. As we continue to explore the vast expanse of space, from the brilliant colors of a nebula to the intricate details of a distant galaxy, the universe never ceases to amaze us. But among the most intriguing celestial bodies we've discovered are the exoplanets, planets that orbit stars beyond our own solar system. These distant worlds have captured the curiosity of astronomers and the public alike, sparking a quest to learn more about their composition, atmosphere, and potential for life. In response to this growing interest, NASA has launched the Roman Space Telescope, a mission dedicated to studying exoplanets and searching for signs of life beyond Earth. Discover and characterize exoplanets and search for signs of life elsewhere in the universe. The mission is set to launch in 2026 and will utilize innovative techniques to capture the first-ever images of exoplanets. One of the most exciting aspects of the Roman mission is its use of coronagraphy, a technique that separates light waves based on their wavelengths. This will enable us to study the planet's atmosphere and search for signs of life without the interference of its host star. Additionally, Roman will use the transit method to detect exoplanets by observing the dimming of starlight as a planet passes in front of it, by analyzing the frequency and duration of these dips in brightness. Furthermore, Roman will employ the radial velocity method to detect exoplanets by measuring the Doppler shift in a star's light as it moves toward or away from Earth. This will allow us to determine the planet's mass and confirm its presence. With these powerful tools at our disposal, the Roman mission is poised to make groundbreaking discoveries about exoplanets and the search for extraterrestrial life. The launch date is eagerly anticipated and the excitement is building for the incredible discoveries that await us. As we continue to explore the depths of space, we're bound to encounter countless wonders that challenge our understanding of the universe. And who knows what other mysteries and marvels await us in the vast expanse of the cosmos. Will you join us in this thrilling journey of discovery? Share your thoughts below.